All right, so this question says, if the function y equals the square root of -3 times x plus c passes through the point -1, 1, what is the value of c? Okay, so we've got -1 and 1, and so it's going to pass through this point somehow. So confirm your answer graphically and use the graph to create a similar question for the same function. Okay. Well, what we could do is, well, I guess, did anyone try this one, or how did you guys go ahead and solve this one? Anyone that did that? Okay, so yeah, the best way we're going to do this is to take this. We know this is a solution. We know this is part of this equation, and that is going to be the x value is -1 right here, and the y value is +1. If we plug those in, we just have c to solve for. So graphically, algebraically, we can do that. And that would look something like this then. So 1 equals the square root of -3 times -1 plus c, and then plus c over there. Okay, so we want to get rid of this radical because the c is kind of caught up underneath there. You can bring this constant over to the other side if you want, and then it would look like this. That's probably what I do. You don't have to. Then when you square both sides, then you have a binomial that's squared, which is easy. That's the FOIL. And then this one just basically gets rid of this root sign. If you didn't do that first, and if you left things like this, you could still do it. This side would be just 1 squared. This side would then be, all of this would be squared. So you'd have to do the FOIL with this radical as one of the terms, which maybe is a little bit more complicated. So it's a good idea to get the radical all by itself on one side. That's what I would suggest. But you could do it the other way too. It should work out the same answer, just might be a little bit trickier. So if we get to here and we square this and we square this, what should we have? 1 minus 2c plus c squared, looks like. And over here, this squared just cancels the radical. Or this would be c minus 1 as well. Okay, so we get to this point. We got c's all over the place. How do we try and solve for c here? What do I do now? Okay, you divide it by -3. Okay, we could do that, and we're going to have fractions all over the place here. That's fine. Any other ideas? Okay, you could expand this one with the brackets. If we do that, we have a constant, and then we have a c term. You might be able to gather like terms without the fractions. So you could do either way. I think probably the expansion probably would be the safest, I would say. So this would be +3 minus 3c over here then, right? Okay, not to say the other way is incorrect, but this might be the safest way. So if I now gather like terms all over to one side, let's bring everything over to the left because this is already positive. So let's add 3c. So what's -2c plus 3c? Well, let me just rewrite this up here actually. All right, so we're going to add 3c. And I'm also going to subtract 3, I guess, right? So we could do both that at once. So 1 minus 3 is -2. -2 plus 3c is going to be plus c squared equals, now this is going to be 0 over there. So if I rewrite this with the squared term first, and in descending order, I get this. And this c now is just kind of like x, right? So you can now just use the quadratic formula if you want, or you can try and factor this. The c is just the sort of unknown x value, looks like. So can I factor this? Two numbers that multiply to -2 and add to 1. That looks like it should be fairly simple. What's that? +2 minus 1. That look okay? All right. So we have c equals -2 and c equals +1. All right. Now, are both of those options valid? So remember what we did with the domain. You have to go back and check to make sure that both of these fit. in our original equation, I guess, somehow. So would it make sense if we plugged in both of those? Why don't we just do that real quick? So y equals the square root of negative 3 times x minus 2, and then minus 2. So there's that one. And what about the other one? Would be y equals the square root of negative 3 times x plus 1, then plus 1. So are there any issues with either of these, I wonder? Any of that, either of those not make sense, or any of those a little bit iffy, or how could we check that if both those C's are valid? What does it say here? Confirm your answer, what? Graphically. Okay, let's check. Good way to do this is just to check with your graphing calculator. Let's plug the first one in here first. So we'll turn this on. Got something there already. Okay, let's just check here. So the square root of negative 3 times x minus 2, bracket, and make sure I can close this into the root sign, and then minus 2. Okay, let's graph that one and see. Okay, now how do I know if this is going to fit for this question? Well, if we look back here, it's got a what? It's got to go through this point. So does that one go through that point? We can look at it and look at, looks like it could. How do we check? Second function, trace, the calculate menu, just hit value. Let's try negative 1 for the x, and we have negative 1, 1. Okay, so that one appears to be okay, I guess, eh? So your C could be negative 2, apparently. Let's check the other one, and that's going to be, just go over here, that's going to be plus 1. So plus 1 here, and then outside that's going to be plus 1. Everyone seeing what I'm doing here? Okay, that one looks like this. So does that work? Well, let's see. Let's plug in negative 1 for our x, and negative 1, 1. I guess that appears, that looks okay too. Okay, so that's the first part of that question there, and we've confirmed it graphically, right? What's the second part? Use the graph to create a similar question for the same function. A similar question for the same function. All right, so for the second part of the question here, for the second part of the question, it says create a similar question for the same function. I guess what you could do is you could have the same function, which is, what was it again? Negative 3x plus c plus c. You could just say if this function passes through the point, and you could just pick any point, like 5, negative 1, then solve for c. So that's it. You could do the same thing, and then of course 5, negative 1 would be over here, and it would look similar to what our graph looked like. Right? The graph would sort of look, kind of like this, and it would pass through a point over here, and you get a different c value. So this x would go in there, y would go in there, solve for c, and you get a different c value. Okay, so that's another type of question that you could create. Number 16. Any final thoughts on that? Any questions about that?